concept of strength of material, how to find the shear force and bending moment diagram of a particular person, as you can see. So last class we did an introduction to strength of material. So for this class, we look at how to apply those concepts we have learned last class to solve problems of this nature. Let's consider a simply supported beam with just a point load. So let's look at how to draw the shear force and bending moment diagram of just a load, a particular load of 20 kN. How do you find the shear force and bending moment diagram of this question? We say the very first task is that we look for the reaction of the beam. So let's look for the reaction using the condition of equilibrium. So my first task here was, okay, before then, I'll try to draw a free diagram, right? So my free body diagram, by the way, I explained the concept of free body diagram last class. We said free body diagram is simply a diagram that shows the external forces acting on a system. So for me to draw this now, I will have the same diagram as illustrated above. Now this is the roller support. A roller support produces just a two reaction. If I have this way, a roller produces just what an upward reaction, right? While a pin support, this is called a pin support, as you can see there, it produces what? A horizontal and vertical reaction. So note that roller produces an upward reaction. Pin produces what? A horizontal and what? Vertical reaction. That's the concept. That's like the concept. That's like the concept there for that particular one there. Alright, let's look at the free body diagram for this. This is a pin. Of course, a pin will have a two reaction there. So I'll have something on this in the top, a horizontal and a vertical reaction. This is last support have just a vertical reaction. This point B, this is my point A. At this center here, I have a 20 kN as my point C. Mind you, said from distance from here to here is 5 meters. Distance from here to here is also what the 5 meters. Observe that I have shown all the external forces acting on this beam. Now, what do you call this? What do you call this? Call this one here RBY. We call this arrow. We call this RBY. Why? So R means reaction at point B on y-axis. No, y-axis goes vertically upwards. So this becomes reaction at point B on y-axis. I'll call this one, I'll call it RAX. Call this one RAY. So this becomes my RAY, RAX, RBY. Alright, let's see how we can calculate reaction. So say the first task, after drawing out your free body diagram, start the result, we do the calculation of our reactions. So let's do the calculation. Calculating for reaction using the condition of equilibrium. By the way, what's the first condition of equilibrium? Summation of horizontal components must be equal to 0. That is, my first part, the summation of H is equal to 0. Some people use solution of what? F of X equal to 0. This and this are still the same thing, right? So from here, check. Listen up. This means addition of horizontal components. Look at this structure. Look at this beam now. Which force acts horizontally? And simply one force, which is this. It acts horizontally. So now, mind you, at this point now, I will now consider right force to be what? Positive and left force to be negative. That's the condition for horizontal components. Now, mind you, this one is moving in this direction, right? In this direction. That becomes what then? A positive RAX. Now, mind you, aside from RAX, which force again is still in this form from this structure here. Observe that I'm just seeing only one, right, which is just this RAX, nothing X again. So it means that RAX is now equal to 0. Mind you, solution H is just only RAX. Drop down equal to and 0. So it means that RAX is 0. That's off. So next up, the second condition says summation V is equal to 0. In this point, we say consider upward towards positive and down towards negative. Now, start with this surface. Solution B. Observe that this is check for the forces that are in this form. Now, this one is going upward, a positive direction. Now it becomes RAY plus this man where RAY is going upward, because a plus RBY. This one too is coming downward, becomes a negative 20 equal to 0. Observe solution B is just RAY minus 20 equal to 0, 0. I have this here. Alright, what's my next answer here? I'll take 20 on that side. So I have RAY plus RBY has been equal to 20 kilonewton. Call this one, call it equation 1. Alright, at this point now, after calling this equation 1, what's the next task? We said there are 3 rules for equilibrium. The first one is function H equal to 0, second one is function V equal to 0, and the third one is what? Moment at the point. So let's take, so at this point now, alright, taking moment at point A. We said always take that point A. Why? Because A has just 2 reactions. Now the take moment at point A, it means that summation MA is equal to 0. In this case here, I will consider clockwise to positive and anti-clockwise towards negative in this case. Alright, so I have this one here. Now for a moment, we said always take moment as what? As when you have 2 reactions. So at point A, and take moment at point A. So it means that anywhere your take moment form is always equal to 0. Right? So the take moment from point A, it means that automatically A is 0. Now if A is 0, what does it mean? It means that this C and B, this reaction C and B will come to A. Now listen up, let's tax now. Let's say if A is 0 now, so it says function A is what? 0. Because the one that from A is 0. This reaction 20, observe, this reaction C. If this C comes to meet A, how will it move? Now the task is that whatever I take moment from is 0. And yet it's important to note. If I take moments here, it means that all the rest, all the force that is remaining will come to that point. If C wants to come to this point now, it will move forward in this direction quickly. If C, this arrow can move this way quickly to get to A, I can't comprehend moving this way to A, it's too long. So the shortest way for this C to move to A is in this direction. What kind of direction is this? Is a what? A clockwise direction, because a positive. So that becomes the force. Notice that moment itself is what? 4 times distance, perpendicular distance. So what's my force for C? The force is what? 20 times distance. From here to here is 5. So I have 5 here. I'm done with C. I clean up C. If this B wants to come to A, will it move in this direction or in this direction? Of course, the shortest one is what? In this form. This form here shows what? An anti-clockwise direction. That becomes a negative. Right? Into what's the force here? That's RBY, is the force here. So I have RBY times from here to here is of course a 10 meter. That becomes 10 is equal to 0. Right? Multiply this, I'll have about 100, right, minus 10 RBY equal to 0. R bracket 10 gives 10 RBY. Mind you, I have this sign here. So take this one, by the way, equal to 0, equal to 0. I'll take this minus 10 RBY here because a positive 10 RBY. You have 100 equals, take this one here, becomes 10 RBY. At this point, get your RBY. I'll divide it by 10. So it means that RBY will be equal to 100 over 10. So RBY is of course 10. 10 what then? 10 kilonewton. So I'll put the value for RBY as 10 kilonewton. If RBY is 10 newton, what's RBY? So I'll go back to my equation 1. So go back from equation 1, right? What's we have that RAY plus RBY is equal to 20 kilonewton. Alright, by the way, let me ignore this for now. So what's RBY? RBY is 10. So I'll put 10 here. So RAY plus 10 equal to 20. Take this one here. I'll have that RAY equal to 20 minus 10. Of course, my RAY is equal to 10 kilonewton. So, of course, my RAY is 10. My RBY is 10, as you can see. So, I'm putting the two reactions for each support. So, I'm saying that RBY is 10 kilonewton. RAY is also a 10 kilonewton. So, I'm putting the value for RAY and RBY. That's the first task. Get your reactions. When I'm done with this reaction, what's the next task? Let's do shear force and bend moment calculation. Alright, at this point now, I'm getting the value for my reaction. RA is 10, RB is 10. When we're done, what's the next task? I'll do shear force calculation. Shear force calculation. We said always take your readings from what? Left hand side. That is upward will be positive, downward negative. If you are taking your readings from right hand side, upward becomes negative, down becomes positive. That's the condition. We said when it comes to the shear force, there are two ways of doing it. Either you choose left hand side process or right hand side process. For left hand side, just ensure that any force going up is positive, any force going down is negative. So by the way, we said left hand side, so I'm moving in this direction, right? It becomes a left hand side concept. So how do you get the value correctly? That's like that. I'll go back to my questions. I have just three forces here, A, C, and B. This is not good. The way normally it's meant to be A, B, C. But I'm saying A before C before B. So it becomes what? A, C, B concept. So now it's not equal to this. Another thing of mine. Last class we said, I heard of this last class. We said, that is for shear force. Shear force always starts with a number, and yes, shear force always starts with a number and then with 0 is. For shear force, always start with number and must always end with 0 is. So in the case of a for shear force and you have a value here, you see have that value here, like a number, a value, you are wrong. So most at the back of mind that shear force starts with 0, starts with a number and end with 0. Let's do this right. At point A, what's my shear force? Go back to your question. At point A, here, this point A, this force is going up or down. Of course, it's going upward. And we say up to what? Positive. What's the force there? RA is what? Is 10. So this becomes what? A 10 kilonewton. Right? When you are done, you said, whenever it comes to shear force calculation, always repeat what you have in first before you consider this section. Now, repeat down my pen first. Now, shear force at C, check the force at C. Is it going up or down? Of course, downward. So, down the force was a negative 20, minus 20. This means what there? A minus 10 kilonewton. You said, repeat this answer down first. So I have repeat this answer down first. Now let's consider section B. Section B there is the arrow going up or down. Of course, upward, but what? A plus 10. I have a plus 10. This becomes what there? 0. Why? Minus 10 plus 10 is of course 0. So as I said, shear force starts with a number and always ends with 0. So this is like shear force calculation. So that's all. That's all. For shear force, two things to note. First things first, what we need to notice is that number 1 is that shear force starts with a number and ends with 0. Number 2, for every new section, always repeat what you have at the top before you write. Consider that section. Look at section A. Neutrally, I have just a 10 going up. RA is going upward. That's 10 kilonewton. I have the same. Now, to consider this next section, repeat what you have here down first. Consider section C. Please, that's the concept behind shear force calculation. And I said, when it comes to your reading, either do a left hand side or right hand side. For left hand side concept, I move this way. I was moving in this pattern because I'm going with what? Left hand side. So left hand side. If it was that I'm going to right hand side, I'll start with what? B, C, and A. That's the right hand side concept. So that becomes your task. Alright, let's do bending moment calculation. Bending moment calculation. Alright. For bending moment calculation, your task is quite simple. Repeat what you have. I have A, C, and B. So I have A, C, and B. Listen up, please. The task is quite simple from the shear force concept, right? So when it comes to bending moment, what are you intending to watch out for? Now, this is first. We know before now that anywhere the taking moment form is always 0, right? So it means that moment at point A, at my point A, moment at point A is 0 automatically. So I have 0. Because I'm looking at point A now, point A becomes 0. See, listen up. For shear force, always start with a number and end with 0. For the moment, it starts with 0 and always ends with 0, please. For shear force, it starts with a number and ends with 0. Bending moment starts with 0 and ends with 0, please. Watch out for those concepts. So say at point A now, bending moment was 0. For shear force, we will repeat this one down first before consider this section. But this one now, you won't repeat this. You don't repeat. Now, at point C, neutrally, listen up. For bending moment calculation now, when we did shear force, we said left hand side reading a bit. Similarly, for bending moment then, we're also using what? A left hand side reading. Such that my clockwise will what? Positive. Anti-clockwise will what? Negative. If I'm taking my reading from left hand side, clockwise is positive and clockwise is negative. But when I take my reading from right hand side like this, if I'm going in this format, right, it becomes a normal visual concept. How? Upward positive, down negative. Clockwise positive, not negative. But I'm going with right hand side becomes the reverse of the case. Right? That's the concept. But take my reading from right hand side. This one becomes a negative, positive. This one becomes a negative, a positive. That's right hand side. But take my reading from left hand side. So at left hand side there, if I'm going to look up in this format like this now, A, and the point that A is 0 automatically, right? So I have 0 there. Come back to C. Moment at C, at point C is 0, 2, right? So moment at point C is what is 0. But mind you, at this point C, observe that there's a particular force here, which is RA, that will come to C. So if RA comes to C, that becomes a 10 times what? 5. So I have plus 10 times 5. Alright, is that all? That's all. Listen up. When I took point at point A is 0. But there was nothing, there was no force here that will come to A. That's why I have just 0. At point C is still 0. Why? Anywhere it take moment form is always 0. So at point C is 0. But mind you, I'm going in what? A left hand side direction as indicated up there. Right? So this one now is a force that can come to this point. So if this RA come to this point here, it becomes 10 times what? 5. So having there. So that will be what there? A 50. It becomes a 50 kilonewton. I'm done with this. Next up, at point B. At point B2 is 0. But mind you, I'm moving what? In the left hand side direction. So these two, 1, 2, these two forces will come to B. So if this one here comes to B, it's going to be in this corner B. That becomes what? A 10 times what? From here to here is 10. That becomes plus 10 times 10. I'm done with this. Next up, if this A, RAY is 10, that's why I'm putting 10 straight forward. So 10, this RA, this force comes here, becomes a 10 times 10, right? If this C comes here, becomes opposite direction is because of a negative direction, that becomes what? 20 times what? 5. Or becomes what? A minus 20 times 5. Why is it minus? Because C will move to B in anti-clockwise direction. So I have this. So this is now equal to this is 100, right? So this is 10 times 10 is 100. 20 times 5 is 100. 100 times 100 is of course 0. So we said shear force starts with a number, end with 0. Similarly, bend on start with 0 and always end with 0. So that's the concept behind bending moment and shear force calculation. Now let's draw the diagram. So repeat down your question. My first task is to repeat the question. From the question there, I have right here. Alright. From the question there, I have something of this nature. Redraw out your diagram given. So I have this a roller support here at point B, 20 kilonewton, right? This is a pin support, right? This point A. So we said this is my diagram. So from here to here is 5 meters, right? So I have the diagram here. So my first task is that I will extend point A downward. Similarly, point C, this is C. I will extend it downward, right? Similarly, I will extend point B downward this way. So it becomes my diagram here. I'll start the upper part here. I'll just do a line this way. Call it 0, 0. Upward is positive, down is negative. Yes. Up positive, then negative. Now look up. Let's start with shear force. Right? Let's start with shear force calculation. So this 0, 0 region is for shear force. For shear force at point A is 10. So at point A, this is my point line A. So this is 0 here, then will be upward. So let's call it 10. Right? At point A is 10. At point C is minus 10. Let's call someone down here minus 10. Let me call someone down here. Let's call it minus 10. Let me call it minus 10. At point B is 0. This is my B, this is 0. I have this. So when it comes to your shear force diagram for point load, connect them what? rectangularly. So you have this. Connect them what? Rectangularly in a rectangular manner. So this is a positive region, a negative region. So I have something of this nature. So this becomes my shear force diagram for that particular question. Let's draw out the bending moment diagram for this question, okay? Similarly, I'll take a region, of course, something of this nature. Hang on. I'll take a region, call here point O and point O. So up becomes positive, down is negative, right? Now, this becomes my bending moment diagram. Now, at point A, what bending moment at point A? 0. So I have here as being 0. At point C, that's 50. So let's go somewhere up here. Let's call it 50, right? At point B is 0. So it becomes plus 0. Now, check for shear force for point load. Connect them in a rectangular manner. For bend moments, connect them with inclined line this way. And what's an inclined line? So I have this becomes my positive region B. So I have a positive region here. So I'll shade this. So this becomes my diagram for bending moment for that particular question. So you can see the diagram in front of you. So it becomes the diagram for the shear force and bending moment calculation of that particular question. So if you find this class helpful, do way to like, subscribe to my channel, share to your friends and classmates so they can learn too. See you in the next class. Go look at example 2, how to find a shear force and bending diagram of 2-point load. This was just a single point load. So look at 2-point load and UDL, UVL and etc.